I think I my brain hurts because you blew my mind with the concept of gravitational lensing at scale. I'm
Okay.
I'm I'm actually extremely impressed. I never thought of that. I thought
Yeah.
about the idea of launching networks of satellites for astronomy,
Right.
but I did not think about using gravitational lensing with that. I,
Yeah.
I,
Okay. Thank you very
I
much.
bow to the master.
Hello, everyone. Welcome to Next Big Future. I have my good friend Warren Redlick here with me. We're going to talk Tesla and also specifically Dojo 2 and 3, which was Elon discussed at the All In Summit. And I'll also discuss some of the other technologies about how uh, Tesla could definitely make very improved chips and how that could also be big money compared to one of Tesla's second largest shareholders, which is Larry Ellison and Oracle. They're actually coming up in fourth place in cloud computing and actually making some big money. So it is possible for Tesla to also make a move in cloud computing against the big three. So I'll briefly go show a deck that I have with some stuff, and then Warren can interrupt me as needed as I go over some of that material.
I would never do that.
No, I want you to. You need to input so I can, give me
No,
guidance on
my
that.
viewers always complain that I interrupt too much.
Right. Okay. So Tesla Dojo 2 and 3. So Dojo 1 is already in data centers. And then Elon said the Dojo 2 will be out in volume next year and be roughly equivalent to an NVIDIA B200. And then Dojo 3 will be out in 2026. And we don't have any specs on that. For people who've
Let me
forgotten,
just interrupt
go
really
ahead.
quick.
Go ahead.
People
Yeah.
might not know what a B200 is. So,
Yeah.
my understanding is that the current generation of NVIDIA chip is called the H100, and that the B200, I think, is out in small volume, but will be a large volume soon, is a dramatic improvement on the NVIDIA H100. So, Tesla is not targeting the previous generation of NVIDIA
Mhm.
chip. They're
Yeah.
targeting they're still behind NVIDIA, but they're not as
Right.
far behind.
Right. So the specs on that are if you use short words, like small words, like normal supercomputing compute is 64-bit. AI only needs like 4 or 8 bits. So then you can get higher levels of compute, with the same chip. And so the H100, when you peak it out, it might get as much as 4 petaflops. And then the B200 can get up to 20 petaflops. So it's 5 times better and then only uses 700 watts instead of 400 watts. So a little less than double the power, but 5 times as much compute for the B200. And then I will briefly go over reminder of where the Dojo was. So Dojo announced a couple years ago, and it uses 15 kilowatts of power for a block of 12 or actually 25 Dojo chips. So they use a lot of power, like 40 times more than a H100, and they get 9 petaflops, so a little over double. So basically, they're 12 times worse or so than the H100. Um, so a lot more power, a lot less compute. So then if they make a big jump up to the 20 petaflops, why I believe that's achievable, and then here's the supercomputer centers where they have 100,000 of them for XAI and 80,000 of them for Tesla, and then increasing, which is world class. Like that's how much the Meta has. So custom AI chips. So if you to burn your code, if you know I'm only going to do this kind of AI, this kind of algorithm, I don't have to program it. I don't have to like say I have an operating system, software, all that kind of stuff, because that slows things down by 100 to 1,000 times. So what we can do is there are things called ASICs and FPGAs, where basically you can code right onto the hardware. Um, and for the table here comparing FPGA, the most programmable in the hardware, eASICs, which are kind of in between FPGA and ASICs. And you don't have to know exactly these technologies because it's actually kind of
I got to nerd
complicated.
out. I got to nerd out. Floating
Yeah,
point gate array and
yeah,
application specific
yeah.
integrated circuit.
That's right. That's right.
I'm
And
old.
then yeah,
I'm old. I know this stuff.
right. Because they've been around for decades, but they never really got a big toehold in the market. But because it was like I never needed to get really, really fast, except for things like crypto mining, Bitcoin
I
mining.
think there
So
was never an application that was compelling enough or large enough that you would get to scale on your ASIC that's specific to it.
right. I think the biggest market now is Bitcoin, mining Bitcoin, where like I need to drop the energy a lot, and I need to use ASICs on these kind of things. So
Right.
if you like have a specific solution that I really want to use loads and loads of compute, less energy, which is like AI, then you can use these things. And there's two major startup companies, each maybe $100 million of funding, something like that, that have made one made ASICs already, and they're going transformer only. So they got their chip. They partnered with TSMC to make the chips, and so they can make them in volume because they're working with someone who just knows how to do it. Just like other people, like NVIDIA doesn't make their own chips, TSMC makes them for them. And then Thales is another company. They're using these eASIC chips, and they're also looking to get, again, highly customized. So this is not an unknown solution. Definitely Tesla knows all about it. And if they decide XAI is going to do a particular way, and I know what my volume of compute is going to be, they can say, I want a special chip that only does that. And then they can get loads of performance, even going beyond what what NVIDIA does, because NVIDIA has a more generalized solution, although they can also try and get more specialized, because this is a easy known path that anyone in the field would know this is a way I can go to get loads of compute. So these etched guys claim to be 10 to 20 times faster than NVIDIA B200s, and they will achieve, you know, all these kind of, low power usage, only consume only 10 watts. So this is something that definitely, if you're not going to change how you do things and can quickly adjust, you're down to the hardware when you do it, then this is an option for anyone to get loads and loads of compute. So 500,000 tokens versus whatever. And the other thing is that OpenAI came up with their Strawberry system, which is something rumored that they could do to get a lot more reasoning. Supposedly that's happened. But that new reasoning, like doing like complex PhD levels in some cases, not all cases, some cases, it uses a lot more inference compute. Inference being actually figuring out the answer versus training. Training is just, I'm going to university, I'm figuring stuff out. I actually go to a job, then I'm doing inference. So that's what is going to happen here. But they use, again, a lot more energy. So again, we can get the performance. We have to figure out how to use less energy. So those are basically the ideas that the reason that using less energy or the increased energy demand on the inference side, it will be a huge deal, is that I think Tesla has the advantage on creating super powerful inference, because a laptop uses about 100 watt hours in its battery. My cell phone uses about like 5-10 watt hours, but then a
Watts.
Tesla bot,
Watts. Sorry, I
watt
want
hours
to.
in the battery, watt hours in the battery, and then also uses less, like zero point 0.1 watts over time, usually, except
Right.
in increased cases. So I'm going by battery size, and then that relates to how much you can use for your chip. So um, the Tesla bot had 3 kilowatt hours, 3,000 watt hours, so 30 times more than a laptop. So that, or
Was it three
the
kilowatt hours? I'm sorry for being nitpicky, but isn't it
yeah,
2.3 kilowatt hours?
yeah, it could be 2.3 kilowatt hours. Yes,
Okay. I
but we
mean,
don't
maybe
know
they've
yet.
changed it.
Yeah, yeah. Well, we're going to have two more versions. Elon says before we get to really million unit volume, we'll have two major versions. We'll get to the third version. Just like Dojo 3 is going to be great, Tesla Bot 3 will be the one that's going to be really great per Elon's expectations. And all that power in Tesla cars, Tesla Solar, and Tesla Bots means that if the world goes to, I need 100 times more power to get two levels up on my AI, then Tesla will be totally advantaged on that, because they're talking about doing distributed compute, all that kind of thing. So two big paths to big money is, if the Dojo 2 and 3 chips succeed, then Tesla could make cloud computing for AI that they can make a business, just like all the other, Amazon, Google, and Microsoft are kind of the leaders there. But the
Let, let me
number, well, go ahead.
let me push back on this. The
Mhm.
general idea of Tesla becoming a cloud AI compute company.
Yeah,
Elon has mentioned it's a possibility, so I'm not saying it's impossible. But
yeah.
what I see is the application specific focus
Hmm.
of Tesla's AI hardware, both the inference chip, the current AI 4 chip, and the next AI 5 chip,
Hmm.
and Dojo 2 and then Dojo 3. The specific application is real world AI.
Hmm.
And the idea is we've got all these robots, whether they're four-wheeled car robots or two-legged humanoid robots, and maybe
Yeah.
some other robots in the
Hmm.
future.
Hmm.
Um, all these robots are out there collecting data, generating data, and then
Hmm.
making mistakes that need to be trained on or learning new tasks that need to be trained on. Now, with the cars, I think that actually fades out. I mean, they'll still continue to improve the cars,
Hmm.
but the cars operate in a very limited domain and they have very limited, I guess I would say, degrees of freedom in what they can do. They can
Right.
go right, left, forward, and back, and there's not a whole lot more that the cars can do.
Hmm.
Robots are going to be operating in a far more diverse environment, and they're going to have far more things that they can do because they're going to be able to use hands to manipulate objects.
Hmm.
So my thesis, okay, is that Tesla's demand for AI compute is going to be so large for
Hmm.
at least the next 10 years and probably 20
Hmm.
for training Optimus to do different things that
Hmm.
any AI compute that they create will be nearly 100% utilized by the Optimus program.
Hmm.
And the other issue is the vast majority of the rest of the world of AI is focused on non-real world AI compute. So
Hmm.
OpenAI, um, Llama,
Hmm.
Anthropic's Claude, the large language models are not real world AI. They are
Hmm.
text AI and they're starting to incorporate some other inputs, but they're really primarily text-based AI.
Hmm.
And, training on video data and then training on real world actions,
Hmm.
right, is very different. And then even like a lot of large language models to some extent depend on human feedback.
Hmm.
I'm not at a certain point with Optimus and with the cars, human feedback becomes irrelevant. You can measure how close you got to what you were trying to do, and you
Hmm.
operate more on the real world feedback.
Hmm.
Did the car go where I told it to go? Did
Yeah.
that object that I was trying to avoid move the way I thought it was going to move?
Hmm.
And you don't necessarily need a human to tell you that.
Hmm.
So I just think that Dojo 2 and Dojo 3 are very important. And the two reasons that they're important are one, Tesla needs a tremendous amount of compute to develop real world driving and real world robots.
Hmm.
And two, while they can rely on NVIDIA to an extent, they have trouble getting enough hardware from NVIDIA to do what they really want to do. And
Hmm.
NVIDIA has something like an 80% profit margin.
Right.
So if Dojo is half is as good as the Blackwell 200, let's say Dojo 2 is
Hmm.
as good as the Blackwell 200, but costs twice as much to make,
Hmm.
right? Well,
Hmm.
Tesla still saves money because NVIDIA charges 5 times what it costs to make the chip.
Right. Right.
So, and I think with Dojo 3, and then there's also the energy efficiency thing, which is probably a big target of Dojo 2 and then Dojo 3 is to get the energy consumption down. But I just
Right.
wanted to clear that point up that although I think there's potential for Tesla to sell cloud AI services,
Hmm.
I think their own internal demand for the cloud AI, for the AI,
Hmm.
is so large, it's basically borderline infinite, that I don't
Hmm.
think there's going to be a lot of AI services left over to sell to someone else. And sorry, there's one other thing.
Hmm.
A lot in my head.
Sure.
On the other hand, you have inference compute in the cars. And you mentioned it like, but I just want to clarify. When you're out during the day and like I play basketball or you're playing tennis or you're walking down the street, you're not reasoning how you're walking down the street. You walk down the street and you react, you drive the car and you're reacting to what's happening. You're not using a lot of higher level reasoning when you drive. when you
Yeah.
walk down the street. At the end of the day, you go to sleep,
Hmm.
and subconsciously your body remembers what didn't go well and what went really well.
Hmm.
And it subtly retrains your neural nets in your brain how
Hmm.
to do better the next, especially if you're doing something like playing tennis or shooting a basketball,
Right.
right?
Hmm.
You're training your body to do that better. And
Hmm.
the at night, this is my own, I might be wrong or might be not a great analogy, but when
Hmm.
you dream at night, your brain is retraining itself.
Yeah.
And the car chip in the car can't retrain itself. So
Hmm.
the training cluster retrains,
Hmm.
but there's value in the inference compute, and I'm not sure Tesla's demand for the inference compute is
Hmm.
infinite. It might be, but
Hmm.
it may be that the inference compute demand is not infinite at Tesla, and they would be able to sell inference compute, which is different than training compute. And I don't,
Right.
maybe you want to address that, your perspective on that point, or maybe you just
Yeah.
want to go back to what you're
No,
doing right
no, no. I can discuss that. So, um, as things evolve, so right now we have to have more and more training because the AIs have to get smarter to get to the really big things we want to do, right? Solving self-driving, solving humanoid real world stuff, solving programming, where we need, like one of the biggest markets is if you can solve programming even to the 90% level, that Gartner says that IT is about like $4 to $5 trillion, and that's broken up into programming at 1.5 trillion and software consulting at like 1.2 trillion, something like that. So nearly $3 trillion of that stuff is there. So
now.
if you can crack that nut, that's one of the biggest um, is opportunities that seems within reach because we're already getting some programming productivity. ARK Invest says that AI has helped programmers be twice as productive. So that's already a big, huge, market, which there's a big debate around. We're spending $600 billion on the chip, or actually spending $150 billion on the chips, and we thus need to make $600 billion in order to offset that. Well, if you can make $3 trillion of that, that solves that problem of that other thing. The other big market is replacing Google search mostly and growing the search area with using ChatGPT, using Perplexity, using Grok to answer your questions. We're already seeing that replacement. You and I use those systems, Grok and others a lot to help us get answers that we're going less to Google search. So that
That's
replacement's already happening.
100%. I use Google so much less now. I use Grok all the time.
Right,
I will say, I still think ChatGPT is overall better.
right, right.
I'm not even talking about the newest versions of ChatGPT. Even ChatGPT regular 4
Right.
is better.
But for things like I want to get a summary of things that are happening on X, right? Then I would then instead of doing a search, I would do a Grok search
Yeah.
to find where that is. So, you know,
Yeah.
and then
But
some other
fundamentally,
question.
my
Yeah.
Google search usage is probably down 90%.
Right, right. And we're in the lead on that, but others will come that way too. So that those use cases there, so the success of that, which is something that we haven't disputed, but other people have. I was at a conference where AI venture capital was talking about it, and they were not sure. They were thinking we're still in the bubble kind of thing. That they weren't of the case that these big markets will happen justifying all the spending, and also creating more profit. So then even bigger than that is robotaxi, self-driving. Those are trillions and trillions of dollars. A massive part of the whole economy that comes from that. So but to go to your question about inference versus training. Once things are training up to a particular level where you're really at, equivalent to human, roughly at human level, then the vast is using it a lot. So then right now training might be bigger than inference, but very soon, and Chamath on All In Podcast says that training inference will become 100 times as big as the inference side of things. So as we get good enough or learn everything we need to have can learn, we'll still be trying to learn more, trying to go to superintelligence, but we'll be using it so much more because it's just like now I replace the workers, just like agriculture, 90% people were farming back 200 years ago, and then suddenly dropped down to 5%, and they're growing more food. So what we do today will get all replaced, and then we'll have create new activity. So I see this evolving quite rapidly over this next few years, where we transition to from training to a lot of inference. And the inference side of things is that the even if Tesla really wants to use it a lot, it may not want to use it all the time. The lumpiness means that, okay, I'm computing stuff, I'm figuring stuff out, but then they need to like take a step back, do some other work. And then meantime, things could be sitting idle. They built this capacity and then things are, 20%, 30%. They could ease off of 100%, in phases as they're doing things because of, just cycles of figuring stuff out. So then you would have spare capacity to, which is what Amazon did with AWS. They were doing a bunch of stuff, figuring stuff out for e-commerce, and then they needed to figure out more. And also by buying and building as fast as they can on the cloud, they reduce their unit cost for compute for everything else. They, were making profit off cloud and didn't, what was an expense of tens of billions of dollars suddenly became a profit center.
I just wondered now that you triggered something in me, so I
Yeah, go ahead.
apologize. I don't
Go
really
ahead.
apologize for interrupting, but I'm going to interrupt.
No, no
Um,
worries.
there's this field of generative AI for images and video, which
Hmm.
I feel is generally still it's like way better than it was. It basically was like it came out of nowhere and it's like pretty amazing sometimes, but a lot of
Yeah,
times, like actually my backdrop image is an AI generated image of my attempt to render pod car in the future.
right.
Um, I think the potential for Tesla's real world AI inference chips and training hardware to train for generating video would, it seems to me, would be likely much better than the current LLMs. And
Hmm.
the LLMs are not limited to that, and there are generative AIs that are working on this, but to have the massive hardware, to have 10 million inference chips sitting in people's garages that
Yeah.
are available, 5, 10 hours a day to generate, um, that may be a tremendous opportunity.
Hmm.
Um, I just don't know, like, I honestly think that the array of things that Optimus will be trained to do is so large that the
Hmm.
demand for training compute will be infinite,
Right.
effectively infinite.
Yeah.
But I don't know to what extent Tesla needs to use the inference compute as part of the training, the extra inference compute as part of the training process. I know they use inference compute as part of the training process, but if you look at like is it called Cortex, the center they built
I think
in
so. Yeah.
Texas? I think
Hmm.
they have maybe 4,000 AI4 chips,
Hmm.
right?
Yeah.
Versus, you know, is it 50,000 or 100,000 NVIDIA H100s?
H100. Right.
So that it seems like they don't use inference compute as much as they use training compute in the cluster.
Hmm.
So there probably is, and Elon has said this, there's a lot of inference compute out there that isn't used. So it may make
Hmm.
sense to use it for that purpose. But I think for a lot of the purposes that we see large language models,
Hmm.
you know, Grok is doing that, not Tesla.
Hmm.
XAI is doing that, not Tesla. And I don't know, this is an interesting question as well. Will the Dojo chip hardware be useful to XAI? Is XAI going to use Dojo, or is XAI going to stick with NVIDIA? Because I don't think XAI is using Dojo now.
Right. I believe that, as they deliver the B200 capability, as they deliver the Dojo 3 capability, that um, XAI will use it more and more for the reason you described before of NVIDIA charging 4 or 5 times more uh, than it is. So if once you crack that solution, then you would, save money, save energy potentially, and then um,
And it's not being able to get the chips.
and
They
not
just
being able
don't
to
make
get the
them.
chips. Well, it seems like you can get the chips now pretty well, but it's just they could X Tesla would listen to XAI more to say, you want that kind of chip? We will make Dojo that kind of chip, right? Or Dojo 3B.
No,
So
I don't. I think that it's like you mentioned the trillions of dollars of computing the programming, and it's like,
Yeah.
no, robotaxi alone, I see in the 10-year time frame, maybe
Mm-hmm.
10, 15 years,
Mm-hmm.
that's $2 trillion in gross profit.
Yeah. Right.
Just not the revenue. The
Right.
revenue is, $10 trillion
Mm-hmm.
in people paying for rides.
Yeah.
And the the maybe gross profits, maybe it's $5 trillion. And then Optimus, there, it's sort of like
40 trillion, something like that. Yeah.
I might be 100 trillion
Right.
in revenue. Uh, you know, it unlocks everything.
Right.
There's so much work that humans do
Yeah.
that humans don't like doing,
Yeah.
that humans aren't good at doing, that humans
Mm-hmm.
are in danger doing,
Mm-hmm.
that we don't even conceive of doing because we wouldn't put a human in that situation.
Yeah.
That all of a sudden Optimus can do things, and I, I I don't know if Elon is correct in saying that it changes what economics is,
Mm-hmm.
but it comes close, and it may get us to that concept of superabundance,
Right.
and the revenue. So replacing programming is good, but I think that there's already companies that are doing that, and XAI and Tesla don't need to do that. And I actually
Mm-hmm.
think XAI's mission is a little different. XAI's mission is to pursue truth,
Mm-hmm.
to
Mm-hmm.
find an AI to understand the universe.
Mm-hmm.
And because it's truthful
Mm-hmm.
to us in
Yeah.
answering our questions, and by the way, I don't think Grok 1 or whatever version of Grok we're on right now is that great,
Yeah.
right? I think it will get better over time.
Mm-hmm.
But which LLM are you going to choose to use? Are you going to choose
Mm-hmm.
the one that gives you the politically correct answer? Or are you going to choose the one that gives you the truth?
Mm-hmm.
And I think it's shocking to me how politically correct Chat GPT can be, and how it seems to be getting worse.
Mm-hmm.
And and Claude and Llama and Gemini. I hardly use Gemini at all.
Mm-hmm.
Um, Mistral, I think, is a perplex. I think Perplexity might be better, but
Yeah.
the opportunity there to be able to answer people's questions
Mm-hmm.
is huge.
Right.
But I just think that I think the getting to your point, I don't think Tesla's engineering dojo for XAI.
Mm-hmm.
I think Tesla's engineering dojo.
Yet, I'm saying that this is in the future. That
No, but
as
even
yeah.
Dojo 3, the opportunity for real world AI is so important. And XAI may adapt and use Dojo for real world AI for its
Mm-hmm.
purposes, but I don't think Tesla can afford to change the Dojo hardware to do anything other than the real world AI they're focused on.
Mm-hmm.
I think
Right.
the value in making real world AI work is so ridiculously large
Mm-hmm.
that anything else becomes trivial.
So the other big thing beyond real world AI is superintelligence. So if you can crack the thing where somehow you're gathering, using Tesla bots to gather information and, studying science and doing things to create some kind of automated learning loop where you can like go beyond, our intelligence, right? Then that pursuit is that infinite, which is a version of real world AI that is like I'm learning from reality to get to superintelligence. So basically, taking the baton from humanity to go, but then we go along for the ride to get to intelligence way, way, way beyond. And so that, if that exists, and I think that you know, Ilya Sutskever, the chief scientist of OpenAI, who's now at, say, Superintelligence, Sam Altman, all people that Elon worked with are of the belief that superintelligence is possible. I think Zuckerberg is not sure, but I think that if you've created something that was, vastly inferior, 10 years ago, barely doing neural networks, and then suddenly you've gone 1,000 times, a million times more, that you know that the scaling stuff that you've bet hundred billions of dollars on is still there, that it would keep going up. That you would say, okay, if I cover Mars with compute, then I would, more and more data
That's a
centers,
t-shirt.
more
That's a
power,
t-shirt.
right? Then that would be something where that could be something that could get super intelligent. So if the intelligence keeps going up, then the arms race doesn't stop. You're at, Dojo 50, Dojo 100, all kinds of mutations and variations are occurring in how you're trying to pursue this goal. So that, yeah, go
Let
ahead.
me just touch
Yeah,
on the superintelligence thing.
yeah.
I think there's a credible case to be made, and it might be wrong, that as long as your AI is dependent on human feedback and human generated data, you
Hmm.
don't really reach superintelligence. And it's the reason why, like let's face it, Elon's a genius.
Hmm.
When you start using real world AI
Hmm.
and you start getting real world feedback that is not dependent on humans,
Yeah.
and I think when I say real world AI, I'm thinking more broadly than what cameras see on a car.
Hmm.
I'm thinking like you have a telescope pointed at space, or you have
Yeah.
a network of telescopes pointed at space, and you make predictions about what you're going to see in space. And
Hmm.
then real world in space gives you a different answer, and now you retrain on what the real world on what the real world taught you. I
Hmm.
think that there's a hunt for data that is
Hmm.
not people don't talk about it enough. There's a
Hmm.
hunt for compute. The hunt for compute is really well understood,
Yeah.
relatively well understood. Not
Hmm.
a lot of people don't understand it, but much better understood. But what data can you find to train your AI? And can you find data that is not human generated? They talk about like synthetic data, like
Hmm.
having the AI generate the data to train itself. And I'm like, yeah, I just fundamentally see that as not working. You need real world. The thing is, there is effectively infinite real world data out there that can train your AI if you can channel it. So
Right.
how the car experiences the world
So
is
I
really,
will set up the next video on SpaceX with
yeah,
here's how you get um, exploring the galaxy in the relatively near term.
yeah.
So people don't know there is something called gravitational lensing, where basically you use the whole sun, the whole star, as a big lens. So the sun is about 1 million miles across. We're a little less than 10,000 miles across. So 100 times wider, and then like a million, 10,000 times bigger, like 100, So the sun is really, really huge. So if you send something out to 20 times further than Pluto, right? That's a gravitational lens point. It's actually a line. So you can keep traveling out that line, and basically you're looking at the opposite side. And then if you're looking at another solar system, or that you could actually see 1 billion times better. So basically, it'd be like the equivalent of sending a probe over there, except you're using the star to do that. So if you surrounded the sun with a halo of many small 1 meter telescopes, then you can explore. It's like I have, and I can have multiple. It's like if I move over like a
You
kilometer or
need
something
one
like that. I'm
meter. They're
yeah,
10-meter telescopes. They're 9-meter telescopes. The diameter of Starship is 9 meters.
right.
They're
So,
eight meter,
but
they're 8-meter telescopes.
but basically mass
They're
production, which
big.
is something that Elon's good at. Mass production. I make 1 trillion telescopes. I can then be constantly real time monitoring.
A
You
trillion.
know, 1,000 things in every solar system out there. So then if it's not like, oh, what's out there? We would then know. We could like see lakes, rivers on the other planets, and also, everything about their atmosphere, look at their moons. And we'd be seeing everything. So we'd be creating this massive array to monitor the whole galaxy. We might be able to have trouble seeing through the galactic center, blah blah blah. But it's basically that you can do that. So going out 3 light days, we can then don't have to travel light years. We just have to get a little bit further away, 20 times faster. We can do it. So then it's within decades that we can do it. So after you colonize Mars, you set up the array and you're exploring the whole galaxy. So then you're sucking in loads of information, knowing everything out there, and then having you know all kinds of super telescopes. So again, mass production. You can't. The future is not low volume. You must have high volume stuff, high volume amount of compute, high amount of data. So so that's something. If any other comments, and then we can have a separate discussion maybe on
I
SpaceX.
think my brain hurts because you blew my mind with the concept of gravitational lensing at scale. I'm
Okay.
I'm actually extremely impressed. I never thought of that. I thought
Yeah,
about the idea of launching networks of satellites for astronomy,
right.
but I did not think about using gravitational lensing with that. I,
Yeah.
I
Okay, thank you
bow
very
I
much.
bow to the master.
Okay, so I appreciate the gratitude, and thank everyone else for listening. And we'll have more talks with Warren about SpaceX and space in our next video. Thank you very much.